Hello everyone, and welcome to this final series of videos where we're going to be talking about factorising, which is the last topic that we need to cover in this module. So first of all, we're going to talk about factorising these expressions, these quadratic expressions. So let's have a look at, for example, question 1b. So in 1b, we've got to factorise x squared add 7x add 10. Now the thing to do here is we need to ask ourselves the question. We're looking for two numbers that multiply together to make positive 10, the number on the end, but they need to add together to make the term in the middle, which is plus 7. So we consider the factor pairs that there are of 10. So that, let's see, for example, is it 1 and 10? Well, 1 times 10 does make 10, that's okay, but 1 add 10 makes 11, not 7. So that's not the correct factor pair of 10. Let's consider then 2 and 5. So 2 times 5 does multiply to make 10, and 2 add 5 also adds together to make 7. So this is the correct factor pair. So this means that this expression can be factorised as x plus 2 and x plus 5. And that's how we factorise a quadratic expression. Okay. There's a lot more that can be said really about all the different pluses and minuses. It can get a little bit more complicated than that. So let's have a look at another one. Let's look at I. Okay, in I we have got x squared minus 2x, and we've got minus 15. So remember, our questions are two numbers that multiply together to make minus 15. Okay. So times to make minus 15, but those same two numbers have got to add together to make minus 2. So let's think about, I'm thinking to myself 3 and 5, so I'm going to write down 3 and 5, but I now need to think, okay, which one's going to be positive and which one's going to be negative? Well, I've got minus 2 here, so if it was the case that this one was negative and this one was the positive one, when I add those two together, that would not come to the right thing. So that would not be the correct factor pair, because then when they're added together, that's going to give me plus 2. So that's incorrect. So let's have a look and see, could it be 3 and 5, but maybe this one's positive and this one's negative? Well, 3 times minus 5 does make minus 15, and minus 5 add 3 does make minus 2. So we found the correct factor pair. So this expression factorizes into x add 3 and x minus 5. And that's that one factorized. Have a look and have a little practice of some of the questions there in question 1. There is another instance I want to look at with you, which is question 1g. Now in 1g, we have got an expression there to factorize, which is x squared minus 1. Now this is a special kind of thing. This is called the difference of two squares, because 1 is actually could be thought of as being 1 squared. When we have this expression, this factorizes into x minus 1 and x plus 1. Because if I was to re-expand this bracket out now, I'd have x times x would be x squared. I would have x times 1 is positive x. I'd have minus 1 times x is minus x. And I'd have minus 1 times plus 1 is minus 1. The positive and the negative x's would cancel out, and I would be left with x squared minus 1. So that is, in fact, the correct factorization. So let's have a look at some other instances of the difference of two squares. So what if I was to have, for example, let's imagine I had 49y to the power of 10 minus 100 x to the power of 6. Now, using these same principles that we've examined in the previous example, this would factorize into 7y to the power of 5 minus 10x cubed multiplied by 7y to the power of 5 plus 10x cubed. And if I was to multiply that whole expression out I would get back to this original expression. Okay, let's have a look at another one. Maybe I went in too complicated too fast there. Let's look at an intermediate one. Let's imagine I was to have, for example, x squared minus 64. Okay, well that would factorize into x minus 8 and x plus 8. Okay, let's have a look at another one. Let's imagine I had this time 4, and I'm going to say 4a to the power of 4 minus 9b to the power of 8. Well, this one would factorize into 2a squared minus 3b to the 4 times by 2a squared plus 3b to the 4. And that's how you factorize things that are called the difference of two squares. Okay, so that's a few examples there of the difference of two squares. Now, if they're feeling super sneaky, which they sometimes can on the course or indeed in the exam, they might ask you to do something like this, to factorize an expression, for example, like m to the power of 4 minus 1. Well, with our knowledge now of the difference of two squares, we can understand that this could be factorized into m squared minus 1 and m squared plus 1. But the question would say factorize fully. Okay, in fact, actually, you can see this question is here. It's question 4K, look. Factorize this one fully. Well, have we factorized this fully at this stage? And the answer to that question, as you can probably imagine, is no, because there's an additional step. This is also the difference of two squares, and in turn factorizes into m minus 1 times by m plus 1. And that whole thing is multiplied by m squared plus 1. So that is the full factorization of m to the power 4 minus 1. It went first of all into those two, and then that one had a further factorization. So that's some introductory examples of factorization. In the next lesson, I want to look at some slightly more advanced ideas in factorization.